Now I want to dig a little deeper into the fact that the log and the exponential functions are inverses of each other. And so just like adding and subtracting are inverses, multiplying and dividing are inverses, logs and exponents are inverses of each other. And so if we have the same base on a log and an exponent function, they will cancel to 1, just like adding and subtracting negate each other, just like multiplying and dividing get rid of each other. Logging and exponenting, yeah, that doesn't really work, but you get the idea. So on this first one, we have log base b, so we have a base number of b, and then we have an exponent expression, b raised to the x power, so b is the base of our exponent as well. Log b and this base b will cancel, and all we're left with is simply an x, whatever the exponent was. It works in reverse as well. If we have an exponential expression raised to a log power with the same base, base b, whatever that number happens to be for our particular example, those will cancel, and we are left with an x. So make yourself a note that the log and exponents with the same base cancel. Now let's use that to evaluate some logs and exponents. All right, this first one is 4 raised to the exponent of log base 4 of 5x. I have a base of 4 for my exponent and a log of 4. So I am just simply left with 5x. I have a 10 here as my exponent base, and I have a log of 4. Remember that that is also an implied 10 as a base. So the 10 and the log 10 cancel, leaving me with simply a 4. Here's another one, natural log. Remember that natural log and the natural base cancel each other because natural log is a base e logarithm. So natural log and natural base cancel, leaving me with 3x. This next one, well, we don't have a matching base. We have a 5 and we have a 25. So at first glance, it looks like we might not be able to use this trick. However, I can rewrite 25 as 5 raised to the second power. So let's do that. If I have log base 5 of 5 squared to the x, and then power of a power rule says I can combine those exponents, multiply them together. So I'm going to have 5 to the 2x if you wanted to rewrite that. But either way, now I can see that I have a log base 5 and an exponent base 5, and all I'm left with is a 2x. Why don't you try this one, similar to number 22, and come back when you're... All right, number 23, you could rewrite 64 as 4 to the third power so that these do have the same bases, log base 4 and an exponent base of 4. Those will cancel, leaving me with the 3 times the x.